Hello there, everyone. Welcome to episode number 696 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. In this week's podcast, my guest is the one and only David Jedynak, Vice President of Strategic Planning at Curtiss-Wright Defense Solutions. David and I are chatting all about the complexities of new defense innovation and what founders must understand about translating tech to the tactical environment. We also examine the similarities and the differences between the defense sector and the tech industry at large, and what investors need to think about when they are navigating the notorious Valley of Death. So, without further ado, please welcome David to Fish Fry. Hi, David. Thank you so much for joining me.
Thank you. Thanks for having me.
Absolutely. Okay, so first up, David, what's the biggest challenge for technology at the tactical edge?
The biggest challenge is understanding how it's the same and how it's different as you get it out to the edge. When somebody says, hey, I want to do X out at the edge, they stop and they look at what's commercially available in terms of the technology, what they're used to using, whether it's in a home lab or a data center or somewhere in between. They say, well, I can make this work. I can make it do what I want it to do in this environment. But then when they have to understand getting into the tactical edge, they have to understand, what does it even mean? What are the constraints? What changes? Is it I have to stick it in a metal box, or is it, gosh, it won't even work because fill in whatever reasons, right? It just, you can't give it that much power. You can't give it that much cooling. It doesn't work in that environment because it needs to be connected to the internet. Those constraints and understanding which are constraints and which are exactly the same, it's no different. Understanding and navigating all of that is really that biggest challenge. You either know how to do it or you kind of don't. And you need to turn to folks who do know how to do that and do that day in and day out.
Absolutely. Okay, so what's the most important thing for new defense founders to understand about translating technology innovation to the tactical edge?
Do not reinvent the wheel. There is so much out there already, just like if you were a founder in some sort of web services, social media, AI, whatever, fintech, you're going to find that there's already a very large and robust tech stack or ecosystem of tech stacks already out there that you are building on top of. You don't start from scratch with everything. What we find in defense is, because it is, back to my first answer, because it's so unfamiliar, that a lot of folks, a lot of founders like, well, I want to do some amazing thing out on the edge. And then they start scratching their head and they start focusing on, oh gosh, how do I make sure that there's rugged hardware out at the edge? I better do that first, instead of realizing that it's already available, that those tech stacks that they're used to may already exist in some of them straight across. If it's software, it may just work straight across. But in other cases, it may be the hardware, and they don't realize that there's analogous hardware to what they're using on their desk right now today out at the edge. And they go off and they reinvent because they're not aware of what's there. I want to add that burns a lot of capital. That ends up putting a lot of burn rate in the dollars, and the people and the timeline, ends up putting it on areas where you don't really need to focus. You go and you buy that, you acquire it, you partner with it to go get that done.
So, compared to the general tech industry, how is defense different and how is it the same?
That's a really good question. There's a lot that's very much the same. And it's probably easier to start there because I think that's where most people would be the most surprised. The things that are the same are the guys making chips. It's a lot of the same companies doing the same sorts of things. Those underlying technologies are the same. The operating systems are going to be largely the same. The programming languages are going to be largely the same. The way that you build out a solution is going, in many ways, is largely the same. It's, get some different nouns and verbs in there. A lot of it's all the same. What's different is a lot of it is either the physical instantiation of what you're building. You don't have a desktop type thing, or 19-inch rack mount server. In a lot of cases, standard stuff that you'd use in that normal world, that stuff is going to be, maybe it's similar from a block diagram standpoint. You go, oh, it's a chip from this guy and a chip from that guy, and they're put together this way, and this is how it works. But the way that it's actually embodied for the defense market is just going to be different. Whether it's the packaging, the power, whatnot, those things are going to be different. The other thing that's going to be different, and this occurs in any industry that you're going into, whether it be automotive or medical or industrial, you're going to find there will be some, I'll just say in broad terms, regulations, whatever those regulations are, the rules, certain things you need to make sure that you answer questions on. They'll be different depending on what you're doing. Anybody who's gone from one part of the tech world into things like fintech will learn there's a bunch of restrictions that they have to pay attention to and make sure that they adhere to certain requirements. Same thing if you're going to medical. Defense is the same thing. You're going to find some of those same sort of things that need to get done. Probably the biggest thing that's going to change, other than hardware requirements about being out at the edge, there is a notion in a lot of tech that kind of everything's always on. The cloud is always there. You can always be connecting back to everything. That's a big difference in the defense world, where your always on connection is not. You can't just assume that that's going to work. In fact, you need to assume it's not going to work, because now you're in a situation where it doesn't go down by accident. It goes down because somebody wanted you to not have that access. So you have to think a little differently in that respect. And what that ends up doing is it impacts the hardware, impacts some of the way you construct your software. It's got to be a little different to live in an environment where there isn't sort of an always on internet connection.
All right. So, David, what's the most important thing for new defense investors to understand about the Valley of Death and how to cross from prototypes to MVPs to ongoing revenue generating production?
It echoes everything I just said, which is, as an investor, not the founders making it, but the investor, you need to understand and you need to ask this question of the founder. What is their innovation versus what is not and should not be reinvented? The whole issue of the Valley of Death is literally it's what we call the technology readiness level scale, TRL scale. Started in NASA, it's used in DoD, defense work worldwide. This concept of going from a basic, I'll say, napkin sketch all the way out at TRL 1 all the way out to TRL 9, where it's fully deployed. It's in use. When you look at TRLs 1, 2, 3, and 4, those are all about in the lab doing certain things, from proofs of concept to I've got it sitting on a bench with not the right hardware, but it's representative. It's a dev kit. It's not the actual deployable hardware, but it's showing what it's supposed to kind of do. TRL 4 is a really easy place for your founders to get to. They go off, they prove the idea, they make it work. They've got a prototype, an MVP that says, yep, I'm able to do these amazing things in this sort of, laboratory, easy environment. When you look at this industry and you say, okay, now how do I get out to a production tail? And a production tail is going to occur at TRL 9, where, TRL 8 and 9, where the government customer has gone and put it through its paces and decides to field it. That transition from 4 into TRL 5, 6, and then 7, which is really a transition from the lab environment with not the right actual hardware, but just the prototype stuff, all the way out to now it's going to work in the actual correct environment and it's in the right form factor. I've built it the right way so it handles all these environments. That transition, that is the Valley of Death. And the reason that it's the Valley of Death is if you can show something at 4, you can get interest in a lot of folks saying, that's great, we love it. But they say, we don't have a contract vehicle or something or other to go and help somebody advance it beyond that point. And then you get back to what I said before. The founders are like, I got to go figure out how to build rugged hardware to get myself from 4 to 7. And then they realize that it's really hard. They're not used to it. It's a whole lot of stuff they've not heard of before. And then they just kind of fall off the cliff into the valley, where they're having to self-fund that because they're reinventing the wheel, or they just don't know enough. They're not connected with the right people to know what all that is. So when you look at that 4 to 7 valley, That's where the investors need to be asking the question, what's your plan, to the founders? And the founders' response should be, we are already aware that there is a complete and total fleshed out, robust ecosystem of technology providers who do defense work, like Curtiss-Wright, who already provide all of that technology that they're looking for, and they moved it from TRL 4 to 7. They need to get on board with that, cross the valley of death. Then that helps those investors and those founders and the customers all rapidly get to the right maturity of the technology such that they can get into that production tail. And until you have the right hardware for the right environment, you can't go to production, which means you can't recognize your return on investment until you've gotten that done.
All right. Well, David, it's time for your off-the-cuff question. So I heard that you went to Disney World for some time. So give us some highlights.
Definite highlights there: the new skin, the redo remodel of Rock and Roller Coaster. It's now the Muppets. That's pretty cool. A lot of good Muppet memorabilia, including the banjo for those who remember in the line there. That's pretty cool. A couple other things that were pretty cool: just being in the park and seeing, or the multiple parks there, really seeing all the engineering that goes into Imagination. And I know that actually one of the rides, I won't say which, but one of the rides actually has Curtiss-Wright technologies in it to help with the Imagination. It's pretty awesome. It's a lot of fun. And again, it's wonderful to see the mix of, here's an idea, how do we make it real, ranging from the simplest of the old sort of like stagecraft type tricks to modern technologies and whatnot, putting it all together to drive the sort of, I'll say, the suspension of disbelief.
I love it. That's fantastic. All right. Well, David, I think that's all I have time for today. Thank you so much for joining me.
Thank you. Appreciate it.
Folks, I've got some super exciting episodes of Fish Fry coming up in the next couple of weeks, including my chat with Alex Senzovsky, co-founder of the Biological Computing Company, about their approach to translating computational principles from living neurons into software for silicon infrastructure. I also chat with Ramuni Nagasetti, Director of Enterprise Accounts at PDF Solutions, about her foundational work in chiplet architecture, her current role at PDF Solutions, and how she sees AI impacting the future of the semiconductor industry. And I also sit down with Dr. Ron Davis from VectorWave to discuss their neuromorphic analog compute and AI native connectivity, and how their unique strategies can enable more efficient spectrum utilization while simultaneously lowering power consumption for complex wireless systems. And also, my 700th, yes, you heard me right, my 700th episode is coming up in late September. But that one's a secret for now. And did you also know that this here podcast was recently marked as the 8th best electronics podcast by FeedSpot? That's right. It's not first, but who's counting, right? Other notable podcasts in this list include the Amp Hour, the Hackaday podcast, and Pick Place podcast. Now, if any of these podcasts seem interesting to you, they do to me, of course, I've included the full list on this week's Fish Fryin' page on eejournal.com and in the description for this week's YouTube episode as well. And also in those descriptions, you'll find a slew of links about Curtiss-Wright Solutions as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, I dig it. You can follow me or us on LinkedIn, and we are also on Blue Sky Social and Mastodon as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by yours truly. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you, everyone, for tuning in. If you know of any cool new technology, or heck, you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of August 28th, 2026, I'm Amelia Dalton, and you've been fried.